So you've bought yourself an Omnichord, probably an old one like this, OM-84 or maybe an OM-36, and you've probably paid a small fortune for it, and perhaps, just perhaps, it doesn't work. This is a bit of a follow-up video in a way to an earlier video I did about a MIDI modification I did to this. That's not actually what I want to focus on today, although that was my initial plan to return to that project. I haven't used this for about a year, and when I got it home to do some more work on that MIDI project, the whole thing didn't work. It was just more or less dead. And after being in a community of Omnichord users and seeing people buy them, and then especially the older ones, and then find that they don't work, I thought it might be useful, because I have a repair to do on this. I thought it might be useful to take this opportunity to just sort of go over a few initial electronic checks that I think are worth doing, whether you're the user of the Omnichord or whether you're a technician, you've got one of these in for repair and you're not sure exactly where to start. I thought I'd try and make this video useful to anyone who's got one, is having trouble with it, and it might lead you down a path of finding the problem that yours has got. Just to describe what mine was doing, I brought this home to do a little bit of work on this modification that I was prototyping, and when I powered it on, as I will do here, at first I got a very dim red light, and then I turned it off and on again and the red light came to full brightness. I thought that was a bit weird, and if I select a chord and strum it, and all volumes are up by the way, it appears to do almost nothing. There is a kind of ruttling sound coming from the speaker as I use the strum plate, but selecting any kind of chord or even trying to sort of start the drum machine doesn't appear to do anything. But there's noise coming from the speaker, there's this thumping sound coming from the speaker, which is normal, and if I turn the tempo dial, I don't know how well that'll come across on camera, but with the drum volume right up, there's a buzzing that changes pitch with the tempo dial there. So my first thought was, of course, open it up and hope it's something simple. Now, spoiler alert, I already know what it is, and I already have a replacement part, and I'm going to cover that repair in this video. But while I'm going in here, we may as well start with a few basics. First thing, let's talk about power. The Omnichord OM-84 uses a 12 volt negative center, 5.5 by 2.1 power jack. Quite often the original adapters come with them, and quite often the original adapters are dead or just have no output. Now if you have no power at all, if you have no red light when you power it on, and I'm just talking about power adapters here, not batteries to start with. If you have no power at all, it's well worth getting yourself a multimeter, even if you get like a $4 multimeter from Amazon or whatever, just to be able to check voltages. I'm going to bring my meter in here. Now this is absolutely not a $4 multimeter, but it doesn't make any difference for this particular example. So if you've got your power supply and you plug it in, set your meter to DC volts, and put the black lead of your meter into the socket, or into the plug rather, and the red lead, touch it on the outside, and you should be able to measure a voltage around about 12 volts. We've got 11.8 on this. This is actually a 12 volt battery, but I'm using this as an example of something you can plug in. So it should definitely be around about 12 volts, and with the wires that way around, it should be plus 12 volts, not negative 12 volts. If you get negative 12 volts with the wires that way around, you've got a positive center supply, and that will not work with the Omnichord. It has to be negative center. So the first things first, check that your power supply is actually working. A lot of these are just down to dead power supplies. Now the thing about replacements, There are negative center 12 volt supplies, and anything around about 1 amp output will be fine for the Omnichord. If you choose to use something like a 12 volt battery, I really like these rechargeable lithium ion batteries. You can find them on eBay and that sort of thing. They're just really useful for any kind of little 12 volt device like this that you quickly want to power up. If you get something like this, these are almost always wired for positive center. So what I do is I think you can probably buy these as well, but I make up a little polarity inverter cable. And all this is a cable that swaps over the positive and negative wires. So as you can see there, I've got the red wire from one side, which changes to the white wire of the other, and then the black wire of one side changes to the red wire of the other. So it just swaps around the connections and makes it into a center negative supply. Then I can plug that into there and it will work with any center negative adapter. This is just a quick one I lashed up. I did make a better one somewhere and I've lost it, so I knocked this one up quickly just as a temporary fix to be able to power this Omnichord. Let's just briefly touch on batteries. I've touched on this in my previous video where these were really common to leave batteries in for a long time, stick them away in a cupboard or in the case or whatever, get them out years later and find that they've had quite a lot of battery leak damage. This was no exception. If you go back to that previous video, you'll see the state that this was in internally when I got it. The battery leak had done an entire lap. I believe that's partly to blame for the fault that this has got, which we will get into. But the battery terminals, it's really common to find them either basically completely gone or have basically no connectivity, no conductivity in those battery terminals because they just get completely corroded. For your first test, I don't recommend putting batteries in them straight away. It's usually better with an external source. One other thing I have seen someone have problems with before is the actual connector, the actual middle pin of the barrel jack connector there. If the connector itself is broken, then your plug can put out all the 12 volts it wants, but the actual socket, if that's damaged, or if you wiggle it and it goes on and off, then you've likely got a damaged socket, and the only real fix for that is to desolder and replace it. I'll try and cover a little bit more of that when we get into this. One brilliant thing about this particular Omnichord is that the full circuit diagram is available on the Omnichord Heaven website, and it's not the greatest circuit diagram in the world, but it's better than nothing, and it is, if you know how to read it, it is a big help. So let's cover a little bit about the internals on this. So what you would normally do is flip it over and remove all the screws around the edges. I'm sorry this is hard to get the whole thing in shot, but I'm trying to show the meat of it really. And you remove this back cover once you take the screws out. I've already done. Ignore this board. This is a prototype I've made. Yours won't have this, and that's going to come out shortly. But it's quite nice to work on actually. It's quite well accessible, and you'll see that the battery contacts on mine are completely missing. I took them out because they were completely corroded by battery leak, and I didn't have any intention of using D-cell batteries in mine, so I took that out and left this space blank. Let's just go over a couple of key points on this. So the power coming in at the bottom comes straight into this board. You notice there are two boards connected by a row of these long connectors. This is the amplifier, power supply, and some of the routing board. This side is the actual digital logic and sound generation board, and also the board that reads the strum plate. Underneath this brown board there's another smaller board which is where all the buttons are, with the button contacts. So you'll see that there's two cables that disappear under this board. They come from the buttons on the front and bring those signals into this board. Underneath this, let me remove this actually, let's pull straight off, on a stock OM-84, and let me remove that red wire as well. On a stock OM-84, there's a couple of main chips on this, which is the microprocessor, and this, which is a timer chip that actually generates 3 square waves that generates the sound. And that sound is processed through a few of the chips and divided down in octaves, which generates the different bass tones, generates all the notes of the strum plate, and that is told which 3 notes of a chord to generate by this chip. So this is the brains of the operation, and it tells this chip, whenever you select a certain chord, it reads the buttons. When you press a button, it fires some numbers to this chip to tell it output these 3 different notes for, let's say, for example, a G major. And that all filters through the rest of the circuit, and then when you touch the strum plate, it triggers a little envelope, like a gate if you like. So the sounds of voices are actually constantly ringing, and when you touch the strum plate, it opens a little gate, and then the dial that controls the note length of the sustain, if you like, of the strum plate tells the gate circuit how slowly to close. So it doesn't sort of make sounds when you touch the plate, they're actually constantly ringing, and it's like someone opening a volume control and slowly turning it down every time you touch one of the notes on the strum plate. The drum machine is triggered again by the brain. Some of it is analog generated, but the actual pulses and the sequences come from the chip. But the actual tempo circuit is part of, I think it's actually on this board. I can't remember, I might be wrong there, but the actual tempo circuit, you noted earlier when we turned the tempo you could hear a buzzing sound. That's because the oscillator for the tempo circuit is separate to the main oscillator that drives these logic chips. And that's where we come to the fault on this. I can tell you straight away, this chip here, the TC40H004P, that is a main oscillator circuit for the digital logic. I can tell you right now, that is dead. It's not running. When this had its battery leakage, the battery leak had made its way all the way around the perimeter, and there was a little bit of acid in the top connector here, so these boards had to be separated and cleaned, and a little bit had got under this chip, and this chip had to be desoldered from the board, cleaned, all cleaned up and resoldered. And if any part on this was ever going to be marginal after that, it was that chip. They're not the strongest thing in the world. It's got obviously 1984 written on it, so it's an old chip, but they are prone to failure. And if that chip and that oscillator circuit is not running, you have no clock on your digital logic. Think about when you have a PC and let's say it has a 2 GHz processor. If that 2 GHz signal isn't there, it's not going to do anything. It's not ticking over. That is the issue on here. I'm going to show on the oscilloscope what signals we have on these pins at the minute. You'll see why there's nothing there, why it's dead. Alright, so looking at the diagram, the oscillator section, the master clock, is here, and it's a little bit confusing in that the main 2 chips they draw actually as a chip. In this one they don't draw the chip, but they actually draw the individual NOT gates in the chip. This chip is an inverter chip. It has 6 inverter gates in it, so it's a hex inverter. And by putting a capacitor and resistor in between a couple of the gates there, you can create a delay state where the output of the inverter will take a little bit of time to discharge before it goes around and loops back into one of the other gates, and you end up with a delay effect that does this. And then if you do that with a very, very small capacitor, that creates a clock signal that goes very, very, very fast. I think it's about 4 megahertz, I think, on the standard speed, 2 or 4 megahertz, I believe. And that speed is adjustable by a couple of pots here, and they are actually what form the tuning pots. So if you look on the bottom of the thing, you'll see a little hole we can put a screwdriver in where it says tune. It's actually fine tuning this master oscillator, and that drives the main processor, microprocessor, and it also drives the clock inputs for the timer chip there that generates the 3 notes for the audio signal. So how would we know if this is not running? Well, first thing we'll do is I have a data sheet with the actual chip here, which is quite useful. We can see on this chip that going around the pins, pin 7 VSS, that is your ground, and pin 14 VDD is your power supply. Now we should have a 5 volt power supply, or there enough, coming from a 5 volt regulator on the back of this board. So what I'm going to do is put these diagrams aside. I haven't got lots of room here, unfortunately. Bring the meter back in. There's a little bit of glare today because the sun's in and out, so I hope you can see this. First thing I'm going to do is check that I have, just pop that out of the way, a continuity. Actually, put this to continuity first. Check that we have a continuity between the black wire of the speaker and this bottom pin, and we do. So we can use this black wire of the speaker for a handy ground point. Now let's put this back to DC volts. Put our ground probe to the black wire and check pin 14 and just see that we have voltage, and we do. 4.7 volts, around about 4.8 volts. It's a little low, that might be down to this faulty chip, but we know we have the logic supply to that chip. So I want to bring in the scope at this point. Now I've had to get a bit of a wonky angle on the camera on the scope because of the glare, but if I bring in my probe. Now I appreciate not everybody has an oscilloscope. I didn't for a very long time, and this is really one for the technicians, but any good technician should be able to do this. I only mention this because I'm surprised to see the amount of people that have said they've taken these into instrument repair shops and the instrument repair shop didn't appear to know what to do with it. So if you're one of those repair shop people and you're watching this, I hope this is of some use to you. Going back to the diagram, this again is, they haven't drawn this in the greatest way, but it took me a few goes to understand what it meant. But they've written the pin numbers on the clock IC there, the 48004, and it's actually pin 4 where there should be a clock signal coming out, going into pin 23 on the main microprocessor. Then it goes into a buffer chip, and the output from that buffer chip, because it drives 3 inputs, goes to the clock chip here. So on pin 4 of this output IC, this oscillator IC, sorry, we should see a clock signal. So if I get the probe and go to pin 4 of the IC, we should be able to see a clock signal, and nothing. Nothing at all. There is a little voltage there, but no clock signal. So that is not turning over. As I mentioned earlier, there was some battery leakage under this. A couple of the pins don't look very good. It did drift in tuning a little bit when I used it last year, so I'm not entirely surprised that it's failed, but we are getting no clock signal. And sure enough, when we go back to our diagram, pin 23 of the mains input on the microcontroller there, we should be able to see something. 21, 22, 23. And you can see it's just stuck as a logic high. There is no clock on pin 23 at all. Also worth feeling around if you feel any heat on any chips or anything like that. There's always a little bit on the timer chip, but I can't find anything else there at all. And again, the output from the 4107, so we should have pin 3 from the 4107 driving the clock to this chip. So 4107 pin 3, nothing at all. So what I'm going to do with this is flip this board over. So there's a couple of connectors here that I'm going to unplug from the other side. They don't come out, I don't think, from this side, but they're actually plugged into the board at the other side. I'm going to unscrew these boards. I'm not going to remove, I am going to remove this, but I'm not going to remove this ribbon connector from the strum plate because it's a devil to get back in. It's quite a delicate cable. It's usually in there really stiff, and if you're careful you can flip the board over and work on it without having to disturb this cable too much. So that's what I'm going to do. So I'm going to disconnect the power. I'm going to take all these screws out and we're going to flip this board over and change this chip. Also, don't forget, as I've forgotten to do here, to remove the knobs on the front. You have to get them off, just pull them off to be able to get the main board out. Now you may notice there's two screws I haven't removed, which is this one and this one under this ground tie. They actually just screw the board to a heat sink for, I think this is the regulator and this is the power amplifier. So you should now be able to carefully lift the board up, and underneath there are a couple of connectors. Can you see the red and black wires here? And these should pull out of the sockets there. Just give them a bit of a wiggle, they disconnect. There we go. And then again, if we're careful, and flip this board over and we'll be able to get access to the chip which is at the top here. So I'll realign my shot and show you what we're going to do. So at this point, just a little word about these connectors here. These are notorious for dry solder joints, and I've actually spotted 2 or 3 at the bottom of mine here. I did actually resolder this from both sides of the board, but any long connector wherever you've got 2 circuit boards that join like this is always really prone to the joint flexing and stress with age, basically. Bearing in mind these 1984, so these are almost 40 years old, and yeah, you can get kind of flexing and stress on the solder joints of these. And it's always worth on any of these reflowing any of these joints and just having a real good look at them. As I say, I've spotted 2 or 3 at the bottom here already that are cracked joints that I must have missed the first time I'd done it. So the first thing I'm going to do is I'm actually going to power up the soldering iron and reflow a few of these. Again, I will check them when I've finished the repair that I'm going to do. So I'm going to reflow those joints first. Makes me wonder if I actually did do them from that side before, because several of those didn't look that great. As with any item really of its age, any electronic item, I always check for dry solder joints especially. So the next thing I'm going to do is I'm going to remove this chip at the top. So I'm going to put the desoldering iron on and we're going to pull that chip. Whenever you do any kind of chip removal like this, make sure when you break the solder joints, you give the pins a wiggle and just make sure they're not soldered to the edge of the pad, because you will start removing pads if you're not careful. Now I can see on this, I'm not sure how well I'll get this really to focus. Oh, okay, not too bad. Let's see if we can get close enough. I can see on this quite a bit of corrosion on the, see that pin there? Underneath that pin in the side of the chip there looks pretty rough. That will be from the battery leak that it had. And this is original 1984 date code. The replacement I have is a 1994, so at least we get 10 years on that. This is an obsolete chip, by the way, so Other chips have replaced it, but I don't know if they're exactly compatible. So I've just found one on eBay. I think I paid £5 for it, and we're going to pop the new chip in and see if it helps. Okay, the new chip is soldered in, and I don't know how well it'll come across on the camera, but you might notice this pin looks a little bit weird. What I mentioned about lifting pads, these old boards don't really stand up to a lot of rework, and bearing in mind this chip has been removed and resoldered once already, this corner pin and the trace where it joins across the chip to the other pin there, the little pad actually did lift, and eventually it did break from the track. So what I had to do was sort of push it back down, scrape a little bit of the solder mask away from this track, and just make sure that a solder joint was flowed across those to make the contact. And I'm just going to get my meter, put it on continuity, and just double check that we do have continuity between the corner pin and that one, and we do. That's fine, so that will be okay. But yeah, they don't stand up to a lot of rework, these, so if you get to a point where you're having to change parts on them a lot, you're going to end up with bodge wires. So let's carefully reassemble this. So I'm going to do the connectors underneath. They should pretty much fall into the same place, but remember that the black one goes to the left and the red one goes to the right. The beauty of doing video, even if you never show it to anyone, is that you can watch your own footage back if there's anything you're not sure of. If you're not going to video it, take loads of pictures on your phone and review them back. It will be a huge help to you to see where that screw went, where that wire went, which way around that plug went, etc. There's no excuse. Everybody's got a phone with a camera on there. Use the resources, they're a huge help. I don't know if I mentioned, by the way, this long connector, these boards do actually come apart. This is just a plug and socket, so it's always worth, if you've got any kind of corrosion or anything in here, take them apart, clean them with isopropyl alcohol and a cotton bud, and you can also use a little bit of switch cleaner, perhaps on a little cotton bud or something. I wouldn't douse it with switch cleaner, but you can always get something like deoxit and put a little bit on a cotton bud, wipe it on the contacts if you want. But if you've had any kind of battery leakage and it's seeped into these, you will have to pull these boards apart and give that a clean to make sure you've got the best conductivity on there, because this can cause quite a few issues if it's not sorted out. When you put these in, give them an anti-clockwise turn first. You'll feel them drop into the original thread, and then screw them clockwise. That way you won't just reef on it and strip the threads out. As I say, I'm only going to put a handful of these in. This back in as well. I have the probe on pin 4. I'm going to pop the power on briefly. There's a clock signal. It's running roughly 4 megahertz. But we're not completely out of the woods yet, and I will explain why. Okay, I have the Omnichord running from my bench power supply here, and currently it's just sitting idle. When I put this back together and put the power on, it did work, but the volume was very, very quiet and very, very distorted. If I turn it right up, I can just about hear it, but it's not coming through properly like it should do. So my first thoughts were around a couple of the voltages coming from the Zener diodes. For example, there's a 10 volt Zener diode which I checked, and it was there, it was fine, voltage was there. Checked a few other voltages and it was fine, but I noticed something. If I select a chord, and I must point out, although you can't see this, the speaker is disconnected from the main board at the moment, so there'll be no sound anyway. If I choose a chord and strum with the volume right down, you see no change on the power supply. As I start to bring the volume up a little bit, every time I strum you'll see it coming up. Now I've got the volume about halfway, and you can see there the current draw is jumping up quite high. If I turn it right up, That's a lot of current being drawn there. Something is wrong in the amplifier section, I'm sure. I also noticed the amplifier chip getting quite hot just in that short amount of time. Now, looking at the circuit diagram, I have some suspicions that if the master volume, increasing the master volume and driving the amplifier chip harder, even without the speaker connected, it's causing excessive current draw. There's a couple of capacitors, in fact there's one in particular I've possibly got my eye on, and I'm wondering if, just going to turn that off, I'm wondering if when it had that initial weird state where I connected the battery up and the power light was kind of dim and then worked again, I'm wondering if one of the capacitors has shorted or has got a partial short in it somewhere. Hopefully you can see this little jumper wire here above the first pin of this chip. That little jumper wire is what carries the 12 volt power supply to the amplifier chip. I'm going to try something. I'm going to cut it. I'm just going to lift it clear. I'm going to reconnect this to the power and see if we still have that fault. Okay, the power's back on. Notice the current draw is a lot lower. I'm going to strum this again and raise the master volume. No, it's not changing, it's just flickering over 13, 14, but the current draw, even in idle state, has dropped quite significantly. There's definitely something going on in that amplifier circuit. Just for a quick look at the diagram to illustrate the point, here's the 12 volt supply that comes into the amplifier chip, and we've cut this temporarily. So there's your master volume pot, goes through a 1 microfarad capacitor, and there's a tiny capacitor there that's just a filter basically, and it goes into pin 4 on the amplifier IC. And on pin 5 we've got this 100 microfarad 16 volt cap here. It's making me wonder, because that one goes down to ground, it's making me wonder if that's got a short in it. And we've also a network here of a 10 microfarad and a 47 microfarad capacitor that both positive sides join to pin 9 on the amp IC again. So there's not actually that much to this amplifier really. It's pretty much just a one chip amp with a couple of external passive components, and that's pretty much it. And it goes into this network here, which is the voltage dividers for the headphone output, so that it brings the voltage down from the amplifier way down for the headphone out. And there's also a switching contact which, when you plug the headphones in, disconnects the speaker. And there's the ground side of the speaker that we've been clipping the probe onto, while it was connected at least, to use as a ground point. So I've got my suspicions on this capacitor. So I think I'm going to pull that and I'm going to measure it, just to actually show where it is on the board itself. This is the 100 microfarad capacitor we're interested in, and a few of the others here are a couple of the smaller ones in relation to that, but it's this one. One side of this negative side should be connected to ground, positive side should be connected to pin 5, I think it was, on the chip, and we're going to have a look at that. I've spent a good amount of time going around this, pulling and testing, and as a precautionary measure replacing a few of the capacitors here. I also pulled and tested the 470 on the output here. They were all fine. The new ones were marginally better, so I put the new ones in to try it. Resoldered the 12 volt link there. Went back and forth a few times, and this is really unusual, but I can only ascertain that the only possible fault is that the chip has gone faulty, the amplifier chip, and that's really rare. Quite often you'll find one of the passive components, like one of the capacitors, as I did in that Sanyo boombox actually that I repaired, has gone bad, but they all test fine. but I have to crank the volume to be able to hear anything. It's causing the chip to draw an excess current, get really hot, and the output's just really quiet and distorted. I even tried completely disconnecting there's a tiny little jumper wire just here, and this is where the signal comes in from the volume control into this 1 microfarad capacitor. I think this is the one that might be the one that I pulled and put back in. Yeah, I think that's the original Sanyo one again. It was fine, but that comes into this capacitor, and then just a quick look on the diagram. That goes into the input on the chip, pin 4. There's a couple of little film capacitors, which again, they're just basically to stop it oscillating. They take very high frequencies off to get rid of any kind of noise on there. They've not shorted out. So yeah, it's a weird one, but the actual chip I think is faulty. So that may be what caused the initial problem with that. Red light not coming on properly, it was maybe drawing excess current, and it's gone. I mean, it's not taking the speaker with it or anything. They measured the speaker's fine. If I plug headphones in, it's just the same, just super low and distorted. So it looks like the amp chip had some sort of failure. It may have caused a fault with the oscillator chip. I don't know. I mean, they're kind of isolated from each other to an extent, but it just seems to be a cascade of faults. I've ordered a new chip. I found one for 3 or 4 quid. It's going to be a bit of a pig to change that, but I'm going to have to take a few pictures and everything of the way the pins are soldered, because a couple of them are bridged together intentionally, and that's done from the factory. Get a new chip in it and see if that fixes that fault. Alright, several weeks have passed, really. The chips arrived. It took 2 weeks to come from Northampton. Not North Korea, Northampton. I'm not sure why, but it did. Maybe it's a postage thing, not sure. But anyway, then I got busy in the interim, so I've got a little bit of time now. I'm going to get on with this chip. So I'm going to remove the old one. I'm going to desolder it first. Then I'm going to unscrew this ground wire, and that should release it from the heatsink, and the obviously the ground wire there as well. So let's get on with it. There's a little nut on the other side, so don't lose that. And free up the heatsink. There's a little shape-proof washer on top of the chip, so again, don't lose that. There we go. Slightly awkward to get out because the pins are, of course, bent at a right angle. For the replacement, I'm going to have to do the same thing, and they're bent very close to the body, so not the easiest thing. And of course, it's smeared with thermal compound, so you'll get grease all over your fingers. Coincidentally, I actually turned the temperature down quite a bit on this. I think I got it set a little bit high before, which is why it was risking lifting pads a bit. But you can run these on these older boards, single-sided boards with the lead solder. You can run these quite a bit cooler than I had it set for modern stuff, and it still does the job, but it puts a lot less stress on the pads. If you can see on the board there, I was quite surprised to see there's 2 part numbers. The 7222 is the Toshiba chip we're taking out, but the M51514AL is a Mitsubishi part, and just looked that up and it's pin compatible, so there may be some Omnichords out there that actually have the Mitsubishi chip instead. I guess it just depends whatever stock was available at the time these were built, and indeed Mitsubishi chips are used elsewhere. I think the main microcontroller is a Mitsubishi, and I think the timer chip, I think that might be Mitsubishi as well, so it's not a complete surprise. But yeah, possibility that if you can't get one of the Toshibas, you might be able to get one of the Mitsubishis. I think they're both obsolete parts, so they've probably got about equal chance of getting either one, but yeah, that was just interesting to note. There's our new chip with the legs bent over, which felt absolutely terrifying to do. Basically had to just press it against the desk. It's a 2007, again original Toshiba Japan part. It is an obsolete chip, so it's not brand new. It does have some solder on the legs. I was aware of this, it didn't warn me of this on the auction listing, so that's not a concern. As long as it works, should be fine. As I say, it's from 2007, so it's quite a bit new. I'm not sure when they were deleted from Toshiba's chip lineup, but yeah, it is an obsolete part, so you just have to find stockists that have still got them, and they can be second hand, so as long as it works, I'm not bothered. Alright, so I've got some new thermal compound. Let's see if I can do this without getting this all over my fingers. I should only need a tiny bit. And I'm sitting behind the heatsink and I can't see what I'm doing. So there's a bit of potluck here. Right, basically I had to solder that upside down, precariously balanced, because I don't want to remove this ribbon cable. That was not easy. I'm going to go in and touch that up, tip it up. There's also 2 pins that have to be bridged, and I've taken a photo for reference. It's the following day. The new amp chip is in, all screwed in, all soldered in, and last night was when I actually did this, and was busy with a few things in the house last night, so I couldn't roll the camera too easily. But after I'd done this, I did a power test and it didn't work. I had a short somewhere. I had a high current draw. It was a good job the power supply was in current limiting, constant current mode, because the voltage plummeted. It said it was running about 1.5 amps, and yeah, something was really wrong. So I went round checking for shorts, and I basically spent all of last night and a chunk of this afternoon going over this, and very long story short, it was a complete screw up on my part, and I'm not going to edit it out of the video. I'm going to include it. Long story short, what it was is, on the other side of this board, where I'd reflowed a couple of these pins, I had a very, very tiny solder bridge between the output pin. It's this one here, the 5th one along on this row, this one that carries the speaker output from this, the negative side of this 470 microfarad capacitor. The pin next to it is ground, and there was a tiny solder bridge on the other side of this brown board between those 2 pins. So what it was doing is it was basically bridging out the AC output from the amplifier chip. And it couldn't be detected on the amplifier side because it was, of course, behind this capacitor. So I noticed the resistance across the speaker was basically a dead short. When I disconnected the speaker itself was fine. So there was a dead short across the speaker terminals on the board here. When I plugged a something like a headphone adapter, like one of these little things, into the jack socket there to break the contacts, the switching contacts there, the short will clear. And I thought, have I got a faulty socket? Is there some sort of weird short? So I desoldered the socket, removed that. The short was still on the board. I started to desolder different pins. I started to desolder, check the resistors on the other side of this. Desoldered this pin, managed to just separate it, and then found a change in the resistance. So I tracked the short down to this board, and when I flipped it over and had a real good look at that, I could see this little tiny solder bridge between the 2 pins. When I cleared that, put it back together, it still didn't work. Do you know what it was? The power supply leads that I've clipped onto this battery terminal that's got a barrel jack on the end of it, I got them the wrong way around. So for several hours I was only turning the power supply on and off, but the capacitor that was here was getting reverse charged, and I noticed that it started to bulge a little bit on the top. So that was another dead giveaway, and as soon as I clipped that off, clipped the clip leads directly onto the right pins, lo and behold, it worked. So I've put a new capacitor on here to replace the one I nearly blew up, and it's likely that the amplifier chip didn't need swapping whatsoever. So I've probably completely wasted about a month of my time waiting for that to turn up and then getting around to actually doing it. That definitely needed doing, but let's put the power on and just show that it works. But I feel like a right fool, but you know, these things happen. So let's add that to the list of things to check. If you're going to reflow any of these pins, front or back, have a real good look to make sure you haven't bridged any pins out, because if you have any weird behaviour, it could be that. So we all do stupid things, and that's certainly one of mine. It's working. It's working. And it's drawing about 180 milliamps at 12 volts consistently. It'll come up a little bit if I turn up the volume. 190. Goes up to about 200 to 250 milliamps when the volume starts to come up, but it's not jumping up to the amp plus that it was before when it had that solder bridge. So that's really frustrating, but it just goes to show when you're trying to work on them without completely removing that board, it does make it difficult to solder. It does make it easy to make solder bridges and stuff. So yeah, again, let's add that to the list of things to check and try not to screw up. Put my Dunce hat on for that one. Okay, screws are back in the board. I'm not going to completely reassemble this because I've got some more work I want to do on the MIDI interface I'm building for it, but up to this point at least now it works. I hope that's been of some use to someone. I hope it highlights how easy it is to do silly things like bridging the connections between the pins on the connector inside there between the two boards, and leading yourself down a bit of a rabbit hole. Happens to the best of us, happens to the worst of us. And I hope it just gives you a few pointers if you have one and you're not sure what to do with it when it's not working properly, where to start and make a basic diagnosis at least. I appreciate that I've used tools like the oscilloscope and the desoldering guns and stuff like that, which not everyone may have, but if you're a technician and you've got one of these in and you're wondering where to start to do some diagnosis around things like the clock circuits, the power circuits, the amplifier and so on, I hope that was maybe of some use and some help to someone. So I'll say for now, thanks for watching.